Hey, sorry, can you hear me? I can't hear anything right now.
Mute. Is the voice now okay?
Is that okay?
Well, actually, you need to ask.
Is it okay now? No.
Yeah.
Test.
Yeah, it's okay.
Okay, cool. All right. So tonight it's about conversation. So feel free to interrupt, comment, ask questions. If you have different opinions, to voice them out. Don't be shy here. So I'll start by acknowledging the fact that as a whole, not just this room probably, but as a whole, our community is very fragmented and very vocal about stuff. And this also applies to what I'm going to say tonight. So in general, people tend to peddle their opinions as actual facts. And yeah, sometimes you have strong technical arguments, but sometimes it's just an opinion. So take that with a grain of salt. So indeed, we are very fragmented as a community. This is based on our background, our experience, our niche, our in this industry domain, and so on. And extending Bjarne's elephant metaphor for the language as a whole, I like this version of each of us having a feel and a taste for a particular piece of C++ and the ecosystem within libraries, techniques, patterns, idioms, and so on, whichever fits our needs or whichever better tracks our experience and our niche that we're coming from. And there's a bunch of good information sources available, from the standard CPP core guidelines to some opinionated best practices, established idioms, books, complex presentations, stack overflow questions, and so on. But mixed up with all the good stuff is also a bunch of myths based on largely obsolete information, bad teaching materials, yes, there's plenty to go around, old company guidelines and so on that's still extant. And of course, the problem of onboarding new engineers on legacy C++ code bases, and they see weird stuff and they think that's the norm. Speaking of Stack Overflow, I want to acknowledge that we've all been beginners at some point. Maybe we still are, or different other things that we're learning now, even in C++. So let's not forget that we need to help each other, and we need to understand that not everyone has our baggage, not everyone has our experience or our point of view, and take some time to listen to others and try to help them if we can, and maybe even learn from others. So how this whole series started, basically I got bored during the pandemic, and I said to Jason that we should try to do an improv series of discussions, free discussions, and attacking some ideas that we had. And we did a very long. I don't recommend that you watch it. It's a very long stream, and it's unscripted. So we just tried various things, and it was fun. We had people online joining, asking questions, making suggestions. So it was kind of a live moderated session where we tried different things and trying to tackle different kinds of myths as we saw them. So I managed to gather some more coherent thoughts into a series of presentations that I did last year, this ++ MythBusters, I did this series at multiple conferences, and people got excited about the ideas, and we had multiple discussions afterwards. People didn't agree with me with all the stuff, and they had many more other ideas, of course. Some of the topics that I covered in, oh, by the way, the slide deck is full of links. I'm going to share the slides afterwards. So they're full of links, references to other presentations, articles, and so on. So if you're interested in a particular thing, maybe remember the slide number and check out the links later on. So things that I covered in the first season of the myth-busting series was stuff like I/O, toolability, regex, optional stuff, opaque interfaces, move semantics, reference semantics, const, access, iterators, and so on. So, like I said, the idea is to not to preach or to establish some rules. These are not rules. These are just topics of discussion. I want to have a dialogue with folks, everyone who's interested. So the format is the usual confirmed, busted, and as programmers, we always have the depends stuff. That's for managers. And I have always some test myths just to set the mood. C++ is inherently unsafe, and there's very little we can do about it. So we've known this for years. Only recently we just started to panic, but we've known this for many years. It's 2023, and we should be able to leverage the power of C++ 20 modules to restructure our code base and improve build throughput. Where are all the compilers? Of course, we have some success stories, but these are pockets of sunshine. Definitely, we're a few years ahead of ourselves. I do suggest you read up this very recent article from a colleague of mine, Cameron. It's a case study of adopting C++ header units in Office code base. And this is part 2. Part 3 is going to follow in maybe a week or so, where we actually share some numbers in the build throughput wins that the Office team had in this pack. But still not modules, header units, we're faking something here. And still MSVC only. Other compilers are somewhere. Another test myth, coroutines shipped in C++ 20. I just saw this tweet today, so this is very fresh. So, and I agree. We've been fussing with this stuff for 3 years now, and I've seen at least 8 or 9 fairly decent presentations on the topic. My favorite one, most recent one I've seen in Toronto from Andreas Fertig is the one that mostly clicked with me. But still, I think we've done a lot of effort just showing how Hello World examples work. And yes, there are some serious projects that are using this for real, but seems to be the work of ivory tower experts. So, state of coroutines, I think Kevin Henny summed it up the best. Still the best slide on coroutines in all the presentations I've seen. So yes, we're gonna get a generators library in C++ 23 if you can afford to be there, but that's just part of the story. Most of us don't just write generators. We're actually interested in orchestrating asynchronous work here, and generators are just for fancy Fibonacci examples if you're into that. Okay, so we got how this works. So let's dig into the actual topics of today. I'm gonna re-emphasize one of the things I did in the previous series, just because I think it's very important, not because I'm paid to build these things, but humans depend on tools. And a thing that I've been hearing for many, many years now is that C++ is not easily toolable, which is in some part true if you compare it to other maybe languages and frameworks out there. But I've been a tool builder for 20 years now. And I build all sorts of tools. And it can be done. It's not easy, it's not pretty, there's lots of bugs, lots of incompleteness. But in all this spectrum of tools that you might need in day-to-day operation, you need to discover, you need to experiment. I think the problem is that we have too many tools to do the same thing. And there's partial overlap, and some are good or are better at some things, some are better at other things. Some have UI, some are crappy command line tools, some are fast, some have performance drawbacks. We need to learn them. I think documentation really sucks for many of these tools, even the commercial ones. So there's a learning curve, there's some experimentation need. Like if I need maybe experiment with a profile, I need to try out several different profilers and learn each one to see how it works, understand its quirks, understand how to use it, understand the power knobs to toggle to make it work how I want it to work. And it's a learning curve, and I need to see more than one before I make an opinion that, oh, this is hopeless, I cannot really use this. I need to try several to see which one works best for what I need, and how I can maybe combine them, or pick a favorite, pick one that works for my project, for my needs. So I think it's a matter of discoverability. It's a matter of learning curve and patience. So I don't think it's true that we're in an ecosystem with a lack of good tooling. They're not perfect, but we have a lot. I'd recommend this as a maybe a starter resource if you're not familiar with a bunch of them. So just check out these links. Jason gathered a bunch of, like a I don't know, C++ starter kit for various kinds of use cases, of course. So do check this out. So I would say C++ has a lot of tools. Not all of them are great, but we have a bunch in the toolbox to check out. And the problem is to get them, to understand them, and get to use them well. Really understand how to use them as a power user. And yes, it may be a difficult journey. So that was a recap of the tooling story, which I care a lot about. Okay, so new stuff. So C++ is slow to compile, and we've all heard this, we've all complained about this. It's not something really new, but it's all about the structure and build configurations you have. So I think most of us believe that we have an intuition of why things are slow, and why certain parts of the build take longer than they should. But we're not always right. So again, we have to fall back on tools. You'd be very surprised. So there are multiple things that can, by the way, share with the rest of us. If you have something.
No, I'm just joking that like the number one place that it goes is input algorithm, because that header takes seconds to pre-process.
Oh yeah, I actually have a slide on something like that, where I have multiple standard headers where I show the impact. So good point. So there's multiple ways you can improve the build, or you can screw it up. So from, of course, build configuration, dependencies, weird dependencies in a project graph, Unity builds, misconfiguration of precompiled headers, experiments with modules that go sour, build caches, and so on. So there's techniques and things you can do to improve your build throughput, but these also can cause problems. So it's a two-edged sword. So you need to build a bit of expertise in how to diagnose these kinds of issues and what tools to use. And I'm going to show a few. What tools to use to identify where things are messed up, and maybe what to do.
I have a question. How can using ranges actually speed up the compilation?
No, it won't. No, these are both reasons to screw up, improve, or screw up the build.
Ah, okay.
So you put the icon of the troll face to wake up the audience, right?
Yes. Yeah, but do call me out on stuff. I love that. You mentioned algorithm. Let me find it. Where is it?
Oh, good, regex. Yeah, I forgot about it now. That's even worse.
Regex is the worst by far. So, by the way, if you don't know this resource, Compile Health, it's not really up to date, but it's good enough. It's again, don't take the absolute raw numbers; they're meaningful. What you should take away from this is the relative impact of some of these things in terms of compilation throughput. So, how expensive each of these are, and if you throw them around carelessly, what kind of impact would you expect to see? And also some common libraries that you might have in your project. Again, benchmarked, and it doesn't show the graph here, but you can expand each of those. So play around with this website. Okay, getting to some serious tools now. So, how many are familiar with Clang FM Trace? Yeah. Okay, good. That's a powerful built-in tool into Clang. If you want some, but it's, I would say, a power user tool. So it has fancy reports, and you have to understand how it is. I mentioned this earlier about the learning curve. It's very nice, but it takes a while to get there. If you want a shortcut, Clang Build Analyzer, it's another free open source tool built on top of F-time trace. I would say it's much friendlier, easier to use, beginner friendly, just as powerful if you want to dig in. So I would recommend starting with this one. If you're at ground zero, don't start with F-time trace directly. Maybe start with Clang Build Analyzer. Very nice tool. I think it was merged upstream, so it's part of LLVM source code now. So do play around with it. On the MSVC side of things, but not so. On Windows, we have had for maybe 5 or more years now VCPerf, a similar tool for benchmarking various things, but mostly compilation. So it's a kind of session recorder kind of thing. It's a command line tool. You can start a session recording, build your project however you want to build it, whatever orchestrator, build accelerator configuration you have. The tool doesn't care how you build your stuff. If it's MS Build or CMake or whatever.
Yeah, it's also really annoying to use because it always resorts the whole list, so you can't drill down by iterative sorts.
Yeah.
I have an open issue about this for
Yeah.
years.
That was my very next thing I was going to comment is on the ergonomics of the UI. So there's two pieces of this for those who are not familiar with the story. So there's a command line thing, which is a tracer, which records an ETL file. It's a dump on disk. So it dumps a very huge file based on how long you record and how many events are collected. So it's a huge ETL trace. It's like a system trace on Windows, the standard thing when you collect diagnostics on Windows. So you have that file, that huge dump on disk. And then there's a graphical application. It's called WPA, Windows Performance Analyzer. It's generic. It's for a bunch of Windows stuff, not just the compilation. It's in the Windows Store. And this is another power user. Although it may fool you that it's UI, it's whatever. It's not easy to use. It's not ergonomic. It has a bunch of weirdness, maybe some bugs, but mostly I would say it's not beginner friendly. Definitely, it's for power users. Very good tool if you learn how to use it. What you have to use, and I would recommend you use, is the new integration in VS, which now Visual Studio, I don't remember which version, 17.6 I believe, don't remember exactly. So now has built-in build insights. So, and you can see a much more friendlier UI inside Visual Studio, so you don't have to mess with session recording manually and so on. So you can start build insights from within your normal Visual Studio UI and build session, and you have built-in reports in VS, much easier to navigate, to understand, fewer details. I would say distilled the important stuff from WP, including functions view, where you can see individual impact of various functions and how their inline affects your build throughput. And yes, people like to mess up with force inline and usually get into trouble in terms of build throughput because of abusing force inlines. So this really helps. And we've done several case studies with large teams, which I cannot name, where they tried to use build insights as an alternative to the traditional BC-perf build insights, the external one. And they all claim it's much easier now. And we're still building this, by the way. It's next thing, you're going to see a templates view where we try to analyze how template instantiation impacts your build throughput and so on. So, and we're going to analyze a bunch of more stuff. So this is under construction, but it's good for production use, what's already shipping. And if you find bugs, you know who to call. Another thing that proves useful, and this has been around in what's it called? Include what you use in the client project,
Yeah.
the Google project.
Let's not about it.
And it's again quality issues. It's not nice to criticize others' work, but quality issues. So we're trying our best here, and we have our own heuristic and implementation, completely different engine, of course. You have the ID experience where you have dimmed out headers that are not used. You have them in dimmed out pale coloring there, and you can clean a bunch of headers in bulk and so on. So again, a productivity boost that can help your build throughput as you work on the source code. So we have the two approaches where you can do batch processing, like diagnostics, like build insights on the whole project analysis, and then dig through the report and fix stuff to get better throughput. And you also have the design time experience where you're actually in some source file and it will show you, hey, like the C# experience, you know, that we all drool about. So you see, these headers are not used. Maybe I should clean them up.
Does the let me
think
just
that works?
try the other also. Let's hope it works. If it doesn't, then
I can repeat the question.
yeah, sure. So the build inside thing that you mentioned, does it also show the part where the compiler is processing all these unused headers or whatever?
It will come into built-in, not right now. So there is information that can be gathered. So the compiler has all this information. The compiler knows which headers didn't contribute to that translation unit. And we're just not surfacing it at the moment, but it will come. It's on the backlog.
Yeah.
All right. So these are the two experiences are complementary. They're going to have some overlap, but they're different workflows. One is design time, one is diagnostics. So a very good resource covering a lot of ground, both in tooling and in techniques. I'm not covering techniques here in terms of what you can do in code to speed up the build throughput. But I do recommend this presentation by Vittorio. It's very good. I'm not exactly sure which is the best version. I think the ACCU version is the longest that I have linked here. The Tel Aviv one from Core C++ might be better because it was after this one. But not sure if that one's published yet. But anyway, it's a very good presentation. Highly recommend it if you're into build throughput. So yeah, C++ can be very slow to compile, but if you really work on it, and if you have good tooling, you can drastically improve it. And we are working as part of our mission in building tools. We also have to make case studies and work with teams to help them improve build throughput. And we've worked with a bunch of teams to help them improve their build throughput on some humongous projects. And it is possible. I'm not claiming it's easy, but it is possible. And they've seen serious wins here. Okay. Moving on. By the way, maybe I'm going too fast, but do stop me. Ask questions, interrupt at any point. I can even go back if you maybe get an idea later. Okay. Maybe while you think about it, I'm gonna drink a bit of water because I ran here, you know.
Well, it's more than 30 degrees outside.
And I live down the street. When I was in school, the people my colleagues who were always late were the ones who lived right near the school. So I live right down the street, so that's why I was late here.
Yeah, that's the issue. You just relax, and when you're far, you think, oh, maybe there is traffic, and someone's late, like I have to start early. And when you're close, it's like, I'll be there. It's no problem.
So I want to continue with the sad state of debug performance in C++. This blog post by, again, same Vittorio, same guy, made the rounds in the C++ community, not because it was groundbreaking, but because people, I don't know, shared it, rallied. Not exactly new information, but it was about time someone really pushed for it. And got the attention that it deserved, so much so that we actually scheduled work to fix it. So, you know, making a fuss makes a difference.
Because like this, we talked about this like 4 or 5 years.
Yeah.
And finally, like GCC and Clang implemented this year. Because
GCC Trunk still doesn't have it. They're working on it.
Okay.
It still doesn't work. I have proof. But what I want to stress out here is that a little blog post carefully shared around and making a fuss in public can convince management to fund these kinds of efforts.
I mean, yeah, like every time I need an MSVC bug to be fixed, I have to open like a bug tracker and then go complain on Twitter.
Yes.
That's the only way it works.
That's the secret sauce. Yes. So for those who are not familiar with the backstory here is that we use Move a lot, and even if we're not using it explicitly, library code uses it behind the scenes, including VSTL, a lot. So the problem is that Move and Forward are basically just fancy casts, as they should be, but in reality there are functions. And when you turn on inlining optimizations, everything goes away and you don't pay any cost for this. And it's well worth having two moves semantics.
There's actually a very significant compile time cost to moves.
So
there is very significant compile time costs, even in release builds, to call to move and to forward. Like 10 to 20% in very heavy.
Because you need to go through the inliner passes.
Yeah, and it needs overload resolution and template instantiation and this and that.
Yes, and that's one of the reasons why in the gaming industry they usually roll their own and they're macro based.
I think so, yeah.
Folks, macros cannot beat that. So yeah, it's valid. Okay, and on debug, of course, these are just regular functions and they're just gonna be function calls. And just to avoid hand waving, if we're looking at this very trivial example, we can immediately see that we have function calls in. So I have GCC 13 there, Clang 14, and some MSVC. I don't know which one. Not that old.
That's actually, I think that's like 2019 latest, give or take a bit.
This one?
Yeah.
No, I think it's even newer.
Okay.
Yeah. So in these compilers, they're all on, and it's all debug, by the way. They're all function calls, which is bad, of course. So if we upgrade, so Clang 16 added this optimization, MSVC 1935, which is, I think, 17.5, yes, 17.5, if I'm correct. We have a very stupid version scheme, in case you didn't notice. And the latest GCC trunk still doesn't have this. I checked today. So there's the notebook link, you can check it yourself. It might be in the works, but it's not merged yet. Okay. So anyway, it's coming. Long overdue, in my opinion. C++ standard moving forward, C++ 11. 12 years, it's okay. Strategy. So compilers can implement some mechanism to acknowledge these meta functions as compiler intrinsics. And Clang does this, like it has special treatment for these functions. It knows about them. MSVC took a different approach where we actually use a custom attribute and we decorate these as intrinsics, and then the compiler knows what to do with this and transform, replace the function call with the cast to the return value of the function. The advantage of this approach, although noisy in the source code, is that it's extensible. And we've had this request from various projects and teams that they have their own move and forward functions that they're using. They're not using the standard ones. Or they have similar functions that accomplish similar things, but in more weird scenarios, and they would like to benefit from this intrinsic optimization. And that's why they requested that it's extensible via a custom attribute. So we decorated the whole of STL with this attribute so that the optimizations kick in, and other teams can do as well if they have similar functions. If you want to learn more, here's a video, here's a blog post. So yes, debug performance in C++, not great. It's improving. This is just a small part of the story. Just a small part of the story.
But one question, it's because this statement, like they said, the performance of C++ in debug is slow. Is it better in other programming languages? Like
many programming languages don't make a distinction between debug and release builds.
Sure, but like
the reason why we make a distinction is because producing release builds is more expensive for us, and we want a faster dev inner loop, and that's where we invented configurations.
Yeah, also because like making your debug information match up with like inlined and eliminated code is kind of really hard.
Yeah, this is another part of the story which I'm not allowed to talk at length because it's work in progress. But debugging release code is another challenge that tool makers are working very hard to address. So that's a different thing. Debugging optimized code where you get inline stuff, you get variables which are missing and so on. You have to make a lot of adjustments to be able to make debugging tools work on optimized code. Because right now, the state of affairs is kind of crappy.
Is MSVC working on like equivalent to OG?
I cannot share that.
Okay.
Yeah,
you can mute the microphone and
because like for
we can talk afterwards. Maybe over beer or something.
Yeah, for example, OG is like from GCC that says deadline optimizations that do not help the debugging information too much.
Yeah, so it's like an O0.5 or something like that.
Well, like
it's a good compromise between getting some decent performance and being able to debug that code.
Yeah.
So dash OG, and it's both Clang and GCC, by the way.
But Clang allows it to O1, which kind of hurts the whole point of it.
I didn't know that. I didn't know how they implemented it. It's weird. It's weird.
Clang has it because they promise parity with GCC in flags, like for most cases.
Because they have a
but they
GCC
do not
driver.
have this like separate mode, so they just say it's one.
I didn't know
That's
that.
fine.
I'm almost sorry I found that. Anyway, we could have done that. So all tool makers are working on a better story. This is not the only approach. So implementing something like a partial inliner or partial optimization is just a way of getting there. But there are several strategies that could help, and all tool makers are working hard on improving this story. But I'm not covering this because we don't have yet good stuff there. And even dash OG doesn't solve all the problems. Okay, C++ will never be a safe language. When I talk about safe, there's all sorts of safety things. Type safety, bounds, lifetime, initialization, object thread safety, and so on. So there's a bunch of safety stuff. People usually think about maybe thread safety and lifetime safety. Usually that's what they think about because they, in general, most of CVEs, most of the problems in the industry with C++ are related to memory safety, but there's plenty of types of safety to go around. And this has been a hot topic from the NSA paper from November last year. This year, everyone did the rounds at conferences covering this topic. I think it competes with AI for popularity this year. So we have a bunch of good presentations. I linked my favorites here, but there are plenty more out there. I intentionally took this screenshot of Sean making this. Okay, so plenty of I don't have links to these ones, but you can Google for them. I think most of them are already published. Maybe this one is not yet published.
It's either on the way or it's already published.
Okay.
I know the rest. No, the rest of them are, and I'm just not sure about this.
These three are for sure published.
Yeah.
I don't know this one.
Yes. Yeah, I don't know for the other three because I saw all three of them.
They're very good. Highly recommend.
Yeah.
Anyway, let's get to the core of the problem. Undefined behavior. So we cannot say we addressed C++ safety until we have eliminated all undefined behavior. Because when you have undefined behavior, you don't get to say that you have safe code. And for arguments about that, I reference to the other talks. And we cannot completely eliminate all undefined behavior because of reasons. There are two categories. I would say there are two categories of reasons why we cannot eliminate undefined behavior. One, which is the argument of historical, because we've had them, and eliminating them would be forking the language, breaking all compatibility, and so on. So the argument of hindsight, we got there, we need to still do it. And you have the other bunch of people who like to build intellectual arguments why having some kind of UB allows some optimization and code movement and so on. And if we eliminate all that thing, we might lose freedom from platform, from different optimization on different platforms and different optimization opportunities for compilers and so on. So they invent all kinds of bullshit reasons why we cannot define behavior. But I think the biggest problem is that we're stuck with it. Even if we agree that we want to get rid of some classes of undefined behavior, and I will reference you here to this presentation, which is very good, it would still be a fork of the language. It wouldn't be the same language. It would be completely incompatible with C++. So we have to stress, like, do we want safety or do we want performance, compatibility, API, stability, portable code, and so on? The best paper by far on the subject is this one by Corentin. This is the link. I think it's called "If We Must, Let's Talk About Safety." So he goes through a bunch of arguments and a bit of the backstory. Of course, Rust is mentioned, barrel checker, lifetime checks, and so on. API and undefined behavior, so on. So this is maybe a 2-hour talk in itself. So if you're interested in the topic, my recommendation, this is the best article to cover. And it covers a lot of ground, so you need like an hour to read it. So taking maybe a bird's eye view here and maybe disconnecting a bit from the mundane and C++, in general, if you want to guarantee lifetime safety, you either need to use some kind of runtime, some kind of garbage collector, or you need to do thorough dynamic memory analysis, something like ASAN and UBSAN, static analysis, and there's ways to statically enforce rules. you can either have them statically enforced by the compiler language rules or by tooling. And in C++, we're only relying on this second part. You can enforce rules like only have multiple immutable references to stuff, so when you're aliasing, or you can have a unique mutable reference. And there are languages who enforce these in different ways, different ideas here, either by the borrow checker like Rust does, or mutable value semantics like Hilo does, and non-direct mutation like pure function language and so on. In C++ land, we basically have to rely on tooling like ClankTidy, MSVC, and other many commercial analyzers. There's plenty to run. So there's multiple ways to attack this problem of lifetime safety, from tooling to a better language, better idioms, and how we use and how we track aliasing in the type system and so on. So there's not a unique way of dealing with these issues. And for C++, we have a bunch of mechanisms at our disposal, but you need to cover a lot of ground to get some confidence. So you need to run ASAN, UBSAN, you need to run ClankTidy analyzers or some other, I don't know, commercial tool that you want to do static code analysis. So there's, and of course, you might want to do fuzzing combined with dynamic analysis and so on. So it's a lot of sweat, a lot of computation, a lot of worry that to build some sort of confidence, because we're relying this as post-mortem, like we need to harden some way. So I would say the new AAA rule for C++ should be almost always analyzed, like some sort of static dynamic analysis, both. You need to worry about this stuff if you want to have some sort of confidence that you're building something safe. And big projects, big corporations that are attractive attack surfaces for exploits and vulnerabilities have to worry about this kind of stuff a lot. And they have to continuously harden and test and sanitize and fuzzy and run all sorts of analyzers continuously to cover a lot of ground and exercise the code. So there's a bunch of C++ security technologies. Some of them are very old, some of them are newer. Not going to go in details. I did a presentation on ASAN during the pandemic. There's a new twist on ASAN, which you might not be familiar with, and that is continuum error. Usually ASAN tracks on the first access to poison memory zone. If you want to learn more about how this works behind the scenes, you can watch this presentation where I explain how it works behind the scenes with shadow memory and poison regions. So usually ASAN tracks on the first access to poison shadow memory. This makes it very difficult to investigate these things in CI/CD systems where you fuzz, where you exercise pipelines to do these things, because you run for a bunch of time and it stops at the first thing, and then you look at the first thing and you say, obviously, and you fix it, and then you have to wait a bunch more hours to get a new batch of results instead of getting the whole list of ASAN violations and work on all of them. So this is a productivity improvement where you don't let it track on the first one. And you can attack this from the other angle of static analysis, because so far I talked about dynamic analysis. So on the static analysis front, there have been a lot of improvements in terms of what you can do to help the analyzers, both in Clang with the lifetime bound and now in MSVC as well, building these sorts of annotations where you have code where it's more difficult to track lifetimes or how references follow a particular lifetime flow in maybe dependent objects or nested objects. So it's similar to how Rust does lifetime aliases. or lifetime annotations, the backticks stuff, if you're familiar with that. If you want to learn more, here's a video, here's a paper.
Another question: is there something similar but opposite, like the lifetime bound states that this reference will be captured, but is there some annotation that this reference will not escape? Because there is blank no escape, which only tells, okay, the compiler may assume it, but there is no diagnostics.
I'm not aware of such an attribute, such an annotation. I think the biggest challenge is in inferring complex situations. So in most situations, the compilers are clever enough to see and follow these transitive aliasing that happens. But in some situations, it cannot, and it can only guess. And the two alternatives is either getting a lot of false positives if the compiler is overly cautious, or miss out important scenarios. And this is where you can help out. I wouldn't say it's a perfect tool, because if you misuse it, you can screw it up even more. But you can help. So I wouldn't use it unless you notice a scenario where it either escapes analysis or it gives too many false positives. So it helps the compiler track dependencies in situations where it would guess, it wouldn't have any certainty. So it's not perfect. It's not perfect. So it helps when, especially when you're building functions like a dispatcher-like functions or forwarders, or when there's a bunch of examples. I don't think in this paper. No, I've seen a better paper, but I don't have it linked here. So there's an article where there's a bunch of very nice examples. I think even in Gabor's video there's a bunch of them, but they're fairly trivial examples where this really helps. So it's not the kind of thing that is enforced. So the compiler doesn't check this kind of stuff. So it's not like Rust lifetime annotations with backticks and everything. So it's not rigorously enforced, and the static analyzer, if it sees these kinds of things, it will track them. But again, it's not an exhaustive process. So you can basically it's you're helping the analyzer. That's what you're doing, and there's no direct way of telling the compiler that, okay, there is no need to track this reference because it won't alias in any way. So you can use these kinds of things to make it safer. It helps. It helps. But I wouldn't rely exclusively on these kinds of things, and I wouldn't rely exclusively on static analysis. So definitely need dynamic analysis. Disadvantage is that with dynamic analysis, you need to exercise those code paths. So you need good test coverage, you need fuzzing, and so on. Okay, moving on. Important bits. How are we on time? Okay. So just rewrite everything in Rust. And when the CTO says shit like this, people usually listen. Yeah.
Just one question. How dare you?
Yeah, just wait. I have more slides. And because we're in the Barbenheim summer.
Yeah, but Oppenheimer is a better movie, so I don't see.
Yeah.
The second should be slow.
Anyway, so there's as you might imagine, people who run cloud services like Azure, AWS, Google Cloud, and so on, they care a lot about safety, and they care a lot about the stability of their systems, and they care a lot about the cost of running those systems, and so on. So this is an interesting paper from Microsoft Azure Security. And the core, I'm not going to bore you with the whole long paper, but if you read it, the link is there. The gist of it is that if you want to build trust, you need to use Rust. If the CTO says so, people listen. Anyway, so it's not just a story. So Rust is already in the Windows kernel since last spring. It's already in those builds. You can easily identify the Rust parts because of their
Serbian domain.
yes, because of their suffix there. Rust is in the Linux kernel since 6.1. And it's making its way more and more components in the operating system. This has been happening for a while, but the public announcement was in April. Top link is up there. So the first two successful experiments were done with direct write and GDI, which are two core components in the operating system, one handling text rendering and one classical graphical rendering. So it's been an exploration process. There's been lots of learning. So this has been a learning process for the teams who have been running these experiments. They evaluated the cost of learning Rust and porting the existing code to Rust. Code was C++ or a mix of C and C++, depending on the project. So the cost of writing it in Rust, getting the team up to speed and being able to do it, building appropriate Rust tooling and necessary pipelines and everything to validate and run the experiments and so on. So it has been a learning process and a case study at the same time in understanding the cost, the impact, the benefits, and so on. And this was, direct write was a fairly small component, the first experiment. A lot of considerations with regards to interrupt between Rust and C++ because you're not building something in vacuum there. You have to interact with various other things. You have to think about operating system and kernel calls in Rust and so on. So you have syscalls in Rust and com interrupt with other components and so on. So various things. And it wasn't as difficult as some thought. And the first experiment was a success. The second experiment was Winter to GDI port to Rust. This is a much bigger component, much more involved, way older. I think it was written in the late 80s. So again, if you want to read more, there's some links and a presentation from the director of operating system security in Windows. Not going to go into all the details. If you want to ask me, I can tell you more, but in the interest of time, I'm not going to go in depth now. But I have more to share. And there's much more on the way. So there are other efforts in Microsoft and in other companies around moving stuff to Rust for safety and for efficiency. An interesting case study that I linked here from Google, Rust Fact versus Fiction, 5 insights from Google's Rust journey in 2022. They call them rumors, not myths like I do. Rust takes more than 6 months to learn. If you look at their study sample, most of their sampled developers, the maximum was 4 months to pick it up.
What does it mean to learn Rust or any language?
To learn programming, to be proficient, not to be an expert.
Okay, yeah, okay, but well, first, like, what's the starting point? How much experience did they have previously?
You're gonna see they come from mixed backgrounds. I have some slides where I show the kinds of directions they were coming from. So a bunch of people came from C++, a bunch of people came from Java background, This is Google's case. In Microsoft's case, we have people coming from C++ or from .NET C#. So it varies. It varies. I don't have proof, but my belief is that people coming from C++ learn Rust faster. But I don't have proof for that.
So that's a myth.
It's a rumor. So Rust compilers not as fast as people would like. Yes, that is true. You pay a cost for all those checks. They don't come for free. So Rust compiler is not that fast. It's even slower than C++ compilation. Okay. Unsafe code interop is always the biggest challenges. That was debunked. Even in the Windows kernel case study, interop was thought to be one of the most difficult problems. And interaction with unsafe Rust regions was thought to be the biggest hurdle, but it wasn't, because when you start, it's very difficult. But as you rewrite more and more, you have fewer and fewer unsafe regions, and you have more civilized and less interop to deal with. So initially, it sounds like it's a high barrier, but over time, it amortizes. Amazing compiler error messages, of course. High quality code produced because you have the LLVM optimizer backend. So why not? You have years of experience on optimizing LLVM IR, because Rust uses the same pipeline as LLVM. Chromium did a case study as well. I linked it here. Rust and C++ interoperability. They had some goals there. Chromium is not yet on the Rust bandwagon. They looked at it, they experimented with it, they're not fully convinced. They have their own things. They're more in the camp of lifetime annotations and using things like OilPan and interesting fat pointers to deal with memory safety issues. So they're not in the Rust band camp. But they did experiments, they did evaluations, they had some goals, criteria for what they would desire to have this as a gateway into the code.
How are you supposed to call unsafe C++ and a safe Rust without unsafe? That doesn't make much sense.
No, whenever you have boundaries, you have unsafe stuff. The idea is to have predictable boundaries, so you know where to look for. So when you have problems, you know that the first thing where you have to look is you have to look at the unsafe blocks.
Yeah.
You have to look at the interop boundary. So you
have the previous slide. There was like a requirement to call C++ without unsafe. If I understood correctly. The first one.
No need for unsafe keyword. That's a go. That's a
go. But that sounds bullshit.
It's a go. You have to strive for it. So the idea is to have less and less need to interrupt. So if you build modular stuff and your surface area is very small, or you interact with the other systems through structured channel rather than sharing memory, then you're okay, because you have a structured communication with the other parts of the system. If you're sharing memory, then you're going to have weird, unsafe interop and marshalling and weird boundaries and unsafe regions, and you have to deal with all that shit, which is unsafe. Yes.
Okay.
But at least you can identify them. They're like big targets. You see them, you look for them. Whereas,
so they can use some sort of RPC and be done.
Where you can have like a civilized structured communication. Yes. But you cannot always do that. And it comes with costs. So using RPC, marshalling, any kind of structured communication which is not sharing direct memory comes with costs. When you can afford it, you can afford it. When you can't. So nothing is free. An interesting mention that people don't usually think about is that unsafe regions in Rust have more UB than C++, if that's possible. And that the reason is that the C++ compiler does some work to do some alias analysis in normal C++ code. And it's not perfect, but in general, it can track aliasing and avoids doing dangerous stuff. Whereas what you put in unsafe in Rust is whatever goes there, it goes there. The compiler doesn't care. It trusts you completely. Anyway.
So on the one hand, we say that we need undefined behavior in C++ to be able to do all sorts of optimizations. And now when Rust wants to do optimizations and not make any analysis on the pointers, then it's like
in unsafe blocks. In the rest of the
yeah,
code, it doesn't have undefined behavior.
Yeah.
So in unsafe blocks, yes, it's all bets are off.
I think it's like perfectly okay. The unsafe blocks are there to do the optimization at the right time.
They're the escape hatch to do the stuff that you cannot do in the core language. That's the escape hatch. The whole idea is that they're needed. A lot of Rust is, and they're not needed just for interrupt. A lot of Rust libraries actually use unsafe code.
I wouldn't complain about more cases of undefined behavior in Rust unsafe because I just simply know the rules how to use the pointers in Rust unsafe. So
the idea is that you're doing these blocks. You assume that you know what you're doing, and those should be up for scrutiny more than the regular code. Like those things should be more thoroughly reviewed, understood. They should be minimized. The regions should be as minimal as possible. It's like I don't know, like holding a lock in multi-threading code. You don't want to hold the lock for the whole operation that you want to do. Like you want to hold it for as short as period as possible, and you want to have certainty that while you're holding the lock, you cannot end up in a deadlock and in situations where you're going to be a performance bottleneck and so on. So it's when you have these regions, they're like big targets. They're red flags. People need to look carefully at them. And I'm not saying it's perfect, but they're necessary because
I guess
you cannot implement everything in
I guess
it's
I would
not
just rewrite this myth in a slightly altered way and call it debugged.
okay.
And I'm going to do it.
Okay, the next one, which is sort of related, successor languages are going to eat our lunch. I listed here 3: Rust, Hilo, and Carbon.
How come Microsoft doesn't have a successor language? Or have you just decided to move to Rust?
It's called Rust.
Yeah, okay.
You didn't hear that from me. No, kidding. Everyone is building something.
Yeah, that's why I'm surprised Microsoft doesn't also, because Microsoft has quite a few languages, right?
A lot. Anyway, Hilo, previously known as Val, fast by definition, safe by default, simple, interoperable with C++, strong on whole part relationships and value semantics. It's basically Swift minus all the class and reference semantics crap that they need to implement for compatibility with Objective-C and their AppKit and UIKit framework. So it's as Swift should have been without the need for reference and classes. So just structs from Rust, if you're familiar from Swift. If you're familiar with Swift, just structs from Swift, no classes. So everything is basically much more simple. Carbon aims to be interoperable with C++, better defaults, no function overloading, no exceptions, no multiple inheritance, no row pointers, no constructors, no nothing. Not even a compiler. We have an interpreter. And Rust is just perfect by construction. If you want to learn more, I do recommend this paper by Lucian Todorescu, the Year of C++ Successor Languages. He goes into details about the problems that each is trying to solve in a different way, which are the strengths of each one, where are the weaknesses, and so on, and the goals of the projects. The article leans a bit on Val, as it was called at the time, because the author is one of Val contributors. But I think it's a good article. So another case study from Android 13, memory safe languages in Android 13. So memory vulnerabilities decreased year over year. And this is for two reasons. One, better tooling and dynamic memory analysis, static memory analysis, and so on. So better tooling for C++ hardening and introduction of memory safe languages in the Android source code base. So if we're looking at a snapshot from Android 13, which is still the current version, the 14 is beta still. So we see Rust is growing, as well as Kotlin. So if we follow this year over year, we see that the blue bars is new memory unsafe code, which means C++ and C, and memory safety vulnerabilities. So the vulnerabilities are decreasing, and the amount of memory unsafe code is decreasing year over year.
So
They're investing more in the other parts.
they just assume if it's C++, it's memory unsafe.
No, there's
Something.
proof.
It is.
It is. It is. Another report that I don't have here. It's shared in my ASAN presentation. The CVE reports year over year in the Chromium code base and in Windows overall. Over 70% of vulnerabilities are memory safety vulnerabilities, basically memory exploits. All sorts of memory exploits, but memory exploits. And those are native code bases. They're written mostly C++. So, and technique of addressing it is dynamic analysis, static analysis, fuzzing, hardening, so on. Lots of testing. Or introducing safer alternatives in either in pockets where you can easily experiment with them, or in pockets which are very sensitive, like pockets where are components which are very critical. So new native code in Android 13, we can see C++ a bit of decrease, but we can certainly see that Rust is growing in Android 13 in Android code base year over year. So it's not a zero-sum game. No reason to panic here. There's plenty of work for everyone. It's just that it is a shift that is going on, and just ignoring it, it's not going to make it go away. I'm not saying let's reconvert. Don't panic. Don't update your CVs or look for other jobs. But
Yeah, that's exactly what I'll do to this night.
yes, exactly. So it's not a zero-sum game. It's increasing year over year. These experiments are gaining traction. They're becoming more mature. Support libraries are becoming more mature. The ecosystem is growing. Enthusiasm in the workforce is growing, but it's going to be a long process. It's not going to happen overnight. All right.
Before we move on, have you considered just taking this whole part and going to a Rust conference with it?
No, I don't need to convince them.
No. It's like we spend so much time on like last couple of C++ meetups, both Serbia and here. I think there was a lot of talk of Rust, and now I'm just feeling, why not just go to a Rust conference and talk about Rust?
They don't care about this.
Why would you talk to them about C++?
No. Talk to them about Rust. Like Rust is great and it's
You don't
increasing
need
in
to
the
convince
price.
them. You don't need to convince them.
Well, it's not about convincing. It's just like, look how amazing it is. Like we
They
won.
know. They know.
We have to convert Rust developers to Rust. We have to convert C++ developers.
Not even that.
Not
you,
yet.
you don't need tomorrow. They're coming on their own. They don't need convincing.
Yeah, that's true.
I really love your presentation because I know Alphabet is about just drop C++, look at the new language.
Well, it has myth in the name. So. Okay. Standard ranges are safe. Let's move on from Rust. Standard ranges are safer than iterators.
Let's keep talking how bad C++ is.
And our experience with iterators since the 90s should tell us that it cannot be worse because there's lots of problems that you can run into with iterators. And I would say much better. I would say the C++ 20 ranges library is awesome. I'm a big fan of it, minus the compilation. Yeah. But it does come with some gotchas, and all the gotchas come from the views. If you're not familiar with the library, haven't used it, or maybe you've seen just toy examples, this is not going to click for you. So you need to maybe watch some other presentations or play with it some more. If you maybe take away something from this slide is that the problems are with the views, and they're not necessarily new problems in C++. It's because views have reference semantics, and they come with all the problems of reference semantics in general in C++. So all the standard gotchas apply. As always with C++, const is shallow and doesn't propagate as you might expect. Question?
Comment on this, I implemented smart pointers for cache and made them deep const. It found a couple of bugs.
Yes.
I can recommend this.
Yes, I agree. I fully agree, but it's not standard C++. So you need to work to build deep constants. So to build truly deep constants, you need to put in some effort. Either use specialized wrapper pointers like that, or implement some kind of deep immutability in the system to identify these kinds of issues. So yeah, but it's again, this surprises people. C++ const is shallow in more ways than you might imagine. I don't want to get into details of span or string view or anyway. Some of these functions in views do caching, which people don't know about. Like begin, empty, filter, drop, these functions do cache. And they're not meant, these views, they're not meant to be hold on to. So they're not meant to store them. You're not meant to reuse them. They're meant for cheap copy and throw around. Like use them temporarily and throw around. Don't reuse them, don't cache them, don't store them. So use them ad hoc. Better copy them because copy is cheap. They're just views rather than try to reuse them. So the same problem and the same kind of advice that I would give for string view or for span or for any other reference semantic language primitives or vocabulary type in C++. So beware of this thing for views and the caching behavior. So if you want a horror story, do watch this presentation from Nico. He goes into many details and examples of this. My favorite one, if I had to pick one, which definitely it's not intuitive. So if you look at this code here, so we're doing a range through a collection of monsters, and we want to filter the dead monsters here. And we want to resurrect these zombies. So we change this Boolean property of those monsters. So we're iterating the dead ones, and we're resurrecting them. And then we want to invoke some function, burn. So this is undefined behavior. So if you look at this code and you wouldn't have these comments, you would say, looks legit. I'm looking for the dead ones, I'm making them alive, and then I'm doing something with them. Seems legit, right? Not working. This is undefined behavior because filter does not expect that you change the invariant while you're iterating using it. So the filter, because of its caching behavior, doesn't expect that you change this property of the elements that you're iterating. And the function resurrect changes this property. So it's sort of similar to iterator invalidation, like you're doing something while you're iterating a collection and you're invalidating iterators. It's not the same thing, but the same kind of gotcha that you wouldn't expect. You need to know about this shit. Anyway, this is the example, just for me, blows my mind.
It means like either resurrect them or burn them. If
if you burn them after resurrecting them, it's still undefined behavior.
Yes, it's still because you're modifying the collection as a whole, and filter is a caching view. That's the problem. The problem is that filter is a caching view.
But if you first resurrect it and then kill it again, then from the view of the filter, like state machine, it doesn't change because it doesn't observe the change that it was resurrected. Because now
I'm not saying this code doesn't work. You will run it and it works. That's the scary part. But by definition, it's undefined behavior. The standard says that this shouldn't work.
Is it really?
Because like undefined behavior, this is how undefined behavior works. It works. That's the this is how undefined behavior.
No, the question is more like, does it have to always satisfy the predicate, or can it wait until we call it to filter again to satisfy the predicate?
Well, you will call the filter again if you just.
Yes, but like, is the code like resurrect then kill again, UB or not?
So let's say only the last one is dead.
Yeah.
Then it doesn't matter.
No, I mean like there is a bunch of them dead.
Yeah.
And like you say, okay, and for everyone, I resurrect, I enter Expo cats, then I kill it again because I need to, I don't know, clean up the road state.
Yeah.
Yeah. Is it still UB if at the end of like your interaction with the object that you are modifying, it's back to being dead? So it's satisfying the predicate again.
So if you flip it twice,
Yeah.
that's fine.
Yeah.
That's fine.
Okay.
Because there's no there's no mismatch between what filter view caches and what reality is. So if you flip it, that's what you were trying to say.
Yeah,
Okay, I misunderstood that. Okay. So yeah, if you restore the predicate to what the filter expects, then it's not UB theoretically.
Okay.
But
you wouldn't do that. So the whole purpose of, let's say, the whole purpose of finding the dead things is that you want to change the state, right? Or let's say you're looking. Maybe this example is not. I thought it was funny, but maybe it's not practical. Let's say you're looking for. A manager is doing a range for loop to find its worst engineers to fire them. So to change an attribute of those engineers, the whole purpose of finding by a predicate in many scenarios is to change the predicate, like to change something about them. Like
And this code would be used to find those worst developers.
But okay. Okay.
And burn them.
Yeah. So this final
Mistake.
I think the issue with this example is that it seems that you do both resurrect and then burn them. Say because like your game engine or whatever is not able to just burn the people.
okay, maybe the confusion is that both lines of code are here. Let's assume you have just one.
Yeah,
So-
that's why.
So if you have just resurrect, then it's UB,
Yeah.
definitely. If you have both, then it's not.
I mean, I think that technically just resurrecting is UB no matter what you do afterwards because you are changing the probability.
Yeah.
If the resulting value.
The argument is that
so-
if after calling these two lines of code there's no observable behavior, so it's as if nothing happened, then it's not UB because it's not like this loop is re-entrant or you can do this asynchronously or something. So we're assuming here like linear execution, synchronous code, and while this block executes, you cannot assume that anyone else is iterating or looking at the filter or anything.
It sounds like the typical problem of definitions when different people understand these definitions in different ways. Than these
Well, that's the whole point of
Yeah.
UB. UB is you're violating the definition. That's a compiler will work.
Yeah.
So the
Yeah,
code
but-
will probably work.
At least if all the people understand the definition correctly, then you can reason about it in a nice way. But if some of them,
The whole point of undefined behavior is that it works now, but if someone in the implementation side of things decides to change something and they say we're not violating the definition, just the behavior, it's your problem because you assumed a behavior, you didn't assume the definition.
I mean, like this conversation is going on right now on the text, so we can just ask them.
Sorry?
We can just ask on the text. This is like this thread is going on right now.
Oh, okay, yeah. Okay. Right. Moving on. And I'm almost done here. CMake is the gold standard for C++ project systems. When it works, it's great. When it doesn't, you're getting your life decisions. There is some help. There's a very short presentation from my colleague Sinem. CMake debugger in Visual Studio and VS Code. I have a demo here. I'm not sure if you're able to read it. Anyway, you get a feel for what's going on. I didn't want to do this live for obvious reasons. Anyway, so you can inspect the properties and how your script is set up, and you can even step through your script to see how things change. And it's sort of a familiar debug experience. It's still not going to teach you how to write good CMake scripts, and it's not going to say, okay, you're using this instruction or this macro which is not idiomatic, or you copy paste this from a Stack Overflow, you idiot, and it's not how you're supposed to do this anymore in CMake. Or
I don't think anything is going to teach you how to
yeah,
write
so
good
it's
CMake.
not going to teach you a better way to rewrite, but it's gonna help you not pull all your hair out and maybe understand stuff as you progress through the script, rather than just guess and just cut stuff from the script until it works. So it will save you on binary search through the script or whatever. So it's a big step, and the reason why I think it's big is because it's in many tools. So it's not just Visual Studio and VS Code; it's also in Rider and CLion. So it's starting to penetrate in tooling. It's still early steps. It's going to improve. Again, it's not an AI assistant that is going to suggest better CMake alternatives and so on. Maybe that sort of thing will come. Who knows? Maybe even AI can do a better job of running CMake stuff. Anyway, but CMake is here to stay, and it's basically the de facto standard nowadays of writing portable build instructions. So the good news is that we have some tooling help. Going back to my tooling story there at the beginning. Yeah. So I'm done here. I would say the overall arching stuff that I keep hearing about people being less enthusiastic about new stuff that comes into the languages in general, that the claim is that we were able to do that shit before we had these fancy new features, and it used to be so simple. Now we have more complicated stuff, more gotchas, more complications. You don't have to embrace every new thing. Many of the new stuff, many of the new things that are coming in the language do help, but again, don't be overly enthusiastic. And like everything, you have to acknowledge the fact that we're trying to bolt some concepts that we're borrowing from other communities, and we're trying to bolt them on our very lovable little thing. So it's not gonna be a perfect fit. Some of the things will work, some of the things will be just weird. That's life. And we need to learn all the new gotchas and when it's good or not to use them. Other myth-busting series, I do like this one by Ciura. This is an interesting series of terrible tips for a C++ developer. They're semi-serious. Of course, Andrei wants to peddle the PBS studio analyzer and so on, but I would say that there are interesting bits in these resources. So maybe click on the one that you find interesting. Anyway, I'm done. And now we can have free conversation around the topic. If you want to go back to a particular slide, I can do that. Did